Section 12.4. Finding percentages with normally distributed variables. Example. Consider the dataset considering of scores on a standardized test. The test scores were normally distributed with a mean of 510 and standard deviation of 95. What percentage of students score less than 510 on the test? I have a normal distribution. Mean is 510 and standard deviation of 95. Let's put this on a graph. I let X represent the test scores, and the numbers on this horizontal axis represents the test scores. Mean is 510. These numbers are 1, 2, and 3 standard deviations above the mean. These numbers are 1, 2, and 3 standard deviations below the mean. Standard deviation is 95, so to find these three numbers, I take 510 plus 95 plus another 95 and plus another 95. So I got 605, 700, 795. To find these three numbers below the mean, I'll take 510 minus 95 minus another 95 minus another 95. So I have 415, 320, and 225. What percentage of students score less than 510 on the test? So 510 is right here. Less than 510 is everything to the left of 510. So if I draw a vertical line down at 510, I want everything on this side because it says less than 510. So this side is less than 510. This side is greater than 510. I want everything on this side. Probability of X less than 510. I just translate this sentence into this symbol here. P stands for probability, which is the percentage. X is the test score, less than 510. So I want to find the percentage of the test score that less than 510, which is this area. Remember, everything under the normal curve is 100%. And 510 is the number right in the middle. The graph is symmetric about 510. So 510 split the graph into two halves. This is 50% and this is 50%. So this blue region is 50%. So there are 50% of students score less than 510 on the test. Next example, we are given the same exact information as the previous one. The question is different though. What percentage of students score less than 650 on the test? So let's go ahead and copy this graph down here. I want to find the percentage of students score less than 650. 510, 605, 700, 650 is somewhere in here. And I want the percentage that is less than 650. This is 650. The values on the right of 650 are larger than 650. The values on the left of 650 are smaller than 650. And I want the value that are less than 650. So I want this region here. This is different from the previous one, because previous one, we just divided into two halves. This is 50%, this is 50%. But this one, this region is more than 50% for sure, but how much more? I want to find the probability when the test scores are less than 650. I am going to use the TI-83 or TI-84 calculator for this. So this is what we're going to put in the calculator. Normal CDF, lower bound, upper bound, mean, and standard deviation. It has to be in this order. To determine the lower bound and the upper bound, you look at the region that you want to find the percentage of. So in this region, I have the right boundary right here. So the boundary on the right side is my upper bound, 650. The boundary on my left side is my lower bound. So in this case, the lower bound is not 225 because it doesn't stop right here. It will continue to the left forever. So we are going to pick a very small number compared to the data values. So in this case, I can pick 0, -100, -1000. Just make sure that it's very small compared to your data values. Mean is 510 and standard deviation is 95. And we will put this in a calculator. If you have your own TI-83 or TI-84 calculators, feel free to use it. If you don't, we can also access the TI calculator for free online. I post it on Canvas. Click on this link. Click Start. On this page, do not worry about these questions or this test. We're not here to take the test. We're here just to use the calculator. So look up here. You see that calculator icon up here? Just click on that. This is a TI-84. To use the normal CDF in this calculator, we go to Distribution, which is this button right here. Click Second Distribution. And we use the second one, normal CDF. So the first one is normal PDF. We don't want to use the first one. We have to use the second one, normal CDF. Enter. Now they're asking for the lower bound. So this lower bound is set at -1 × 10 to the 99, which is a very small number. You can leave it like that, or you can replace it with -1000. The upper bound in this case is 650. My mean is 510. And my standard deviation is 95. Enter. So I have normal CDF, lower bound, upper bound, mean, standard deviation. Enter. This is my answer. I got 0.92971666473. I forgot to give you the rounding instruction here. So let's say round to 4 decimal places. We do not always round to 4 decimal places. Please always read the instruction to follow the rounding direction. This digit is 1, so I round down to 0.9297. And the question is asking for a percentage, so I convert this into a percent, 92.97%. Example, the weights of a certain dog breed are approximately normally distributed with a mean of 62 pounds and standard deviation of 6 pounds. Find the percentage of dogs of this breed that weighs more than 55 pounds. My X is the weight of the dog. and the data is normally distributed. Mean is 62 pounds and standard deviation is 6 pounds. So let's put that on the graph first. I have a bell shape, X representing the values on my horizontal axis, which is the weight of the dogs. Mean is 62. To find the values that are 1, 2, or 3 standard deviations above the mean, I'll take 62 plus 6 plus 6 plus another 6. So I got 68, 74, and 80. To get the values that are 1, 2, 3 standard deviations below the mean, I'll take 62 minus 6 minus another 6 minus another 6. So I get 56, 50, and 44. They want me to find the percentage of dogs that weigh more than 55 pounds. So I'm going to locate 55 pounds on this horizontal line first. 55 pounds is somewhere here, closer to 56. I have two regions. One is below 55 and one is above 55. I want to find the percentage of dogs that weigh more than 55 pounds. So this is 55. More than 55 pounds is everything to the right. So I'm looking at this region. So looking for probability of X is greater than 55. The percentage of the dog's weight that is greater than 55. I'll still use normal CDF, lower bound, upper bound, mean, and standard deviation. To find lower and upper bound, we look at our region. In this region, this is my left boundary. The left boundary is my lower bound, which is 55. My right boundary is not 80. It will keep going forever on the right side. So in this case, I'll just pick a very big number, like 1,000, 10,000. Make sure that the number is big compared to the data values. So my lower bound is 55. My upper bound, I'll choose 1,000. Mean in this case is 62. And standard deviations is 6. And I use my calculator for this. To get the normal CDF, I need to go to my distribution list. So I hit second distribution and I use the second one, normal CDF. My lower bound in this case is 55. Upper bound is a very big number. In this case, I use 1,000, but you can use 10,000 or 10 to the 99. Mean is 62 and standard deviation is 6. Enter. Normal distribution, lower bound, upper bound, mean, standard deviation. Enter. And this is my answer. The question does not give me any routing instruction. So I'll just give you an instruction now, just round to 4 decimal places. We do not always round to 4 decimal places, so always read the instruction. This digit is 2, so I'm going to round down to 0.8783. And the question we're asking for a percentage. So I convert this decimal into a percent. That is 87.83%. Example, the annual rainfall in a certain region is approximately normally distributed, with mean 33.5 inches and standard deviation 5.6 inches. Question A. What percentage of years will have an annual rainfall of less than 30 inches? Let's go ahead and draw the graph for this distribution. I have a normal distribution with mean of 33.5 inches. And the question was asking for the percentage of the rainfall that is less than 30 inches. Let's locate this 30 inches on this graph right here. This is 33.5. 30 is less than 33.5. So 30 is somewhere on the left of 33.5. This is 30. And I want the region that is less than 30 inches. So this is 30. Less than 30 is to the left. So I want to find this left region here. I'm going to find probability of x less than 30. And I'm using normal CDF, lower bound, upper bound, mean, and standard deviation. To find the lower bound and the upper bound, I look at my shaded region here. The right boundary is my upper bound, which is 30. My left boundary, I don't have one because this will keep going to the left forever. So I just choose the very small number. So I'll choose negative 1,000. Mean is 33.5 and standard deviation is 5.6. And I'll put this in my calculator. To get to the distribution list, I hit second distribution and I choose the second one. Lower bound in this case is negative 1,000. For the negative sign, make sure you use this button right here. Do not use the minus sign. Upper bound is 30. Mean is 33.5. And standard deviation is 5.6. Enter, enter, enter. And this is my answer. They didn't give us any routing instructions, so just round it to 4 decimal places. But again, in your homework, please read the instruction. This digit is 8, so I round up to 0.2660. And the question is asking for percentage. I'll convert this decimal to a percent, and that is 26.60%. Question B. What percentage of years will have an annual rainfall of more than 40 inches? Let's put that on a graph. I have a normal distribution with mean of 33.5. And I want to find the percentage of years with rainfall of more than 40 inches. Let's locate 40 inches on the graph. 33.5 is here. 40 is greater than 33.5, so it's to the right of 33.5. So it's somewhere here. And let's draw the vertical line to split it up. I have the left region and the right region. I want the region that is more than 40. So more than 40 is to the right of 40. So I want this right region. I want to find the probability of x is greater than 40. I'm using normal CDF of lower bound, upper bound, mean, and standard deviation. To find the lower and the upper bound, I look at my shaded region here. The left boundary is my lower bound, which is 40. The right boundary, in this case, I don't have the right boundary because it keeps going to the right. So I just choose a very large number compared to the data values. So in this case, I can choose 1,000. Mean is 33.5 and standard deviation is 5.6. And I put this in my TI-83 or TI-84 calculator. I need to get to my distribution list first. So I hit second, distribution, and I choose the second one, normal CDF. Lower bound in this case is 40. Upper bound is 1,000. Mean is 33.5 and standard deviation is 5.6. Enter, enter. This is my answer. Let's round this to 4 decimal places. This digit is 7, so I round up to 0.1229. And I'll convert that into a percent. So that is 12.29%. If the question only asks for the probability, you can leave your answer as a decimal. But in this case, they were asking for percentage. So that's why I have to convert that into a percent. C. What percentage of years will have an annual rainfall between 29 inches and 35 inches? Let's put these numbers on a graph first. I have a normal distribution with mean of 33.5. I want to find the percentage of years will have an annual rainfall between 29 inches and 35 inches. This is 33.5. 29 is to the left of 33.5 and 35 is to the right of 33.5. And I want the region between 29 and 35. This is the region between 29 and 35. I want to find that region. Probability of x is in between 29 and 35 inches. I'll still use the normal CDF with lower bound, upper bound, mean, and standard deviation. Lower bound and upper bound are the boundaries of my shaded region. So this is my shaded region here. I have the left boundary is 29 and the right boundary is 35. The left boundary is my lower bound and the right boundary is my upper bound. Mean is 33.5 and standard deviation is 5.6. And I'll put this in my calculator to find the answer. To get to the distribution list, I'll hit second, distribution, and I choose the second one, normal CDF. My lower bound in this case is 29. Upper bound is 35. Mean is 33.5 and standard deviation is 5.6. Enter, enter. This is my answer. And let's round to 4 decimal places. This digit is 7, so I round up to 0.3948. And I'll convert this into a percent. That is 39.48%. Again, the reason why I convert this into a percent because they ask for a percentage. Question D. What percentage of years will have an annual rainfall between 30 inches and 40 inches? Let's put that into a graph. I have a normal distribution with mean of 33.5, and I want to find a percentage of annual rainfall between 30 inches and 40 inches. 30 inches is less than 33.5, so 30 inches is a number to the left of 33.5, and 40 inches is greater than 33.5, so 40 inches is a number to the right of 33.5. And I want to find the percentage between 30 and 40 inches. So I want to find this region that is between 30 and 40 inches. Probability of X is between 30 and 40 inches. I'll still use the normal CDF. The lower bound, upper bound, mean, and standard deviation. In this region, my lower bound is 30 and my upper bound is 40. Mean is 33.5 and standard deviation is 5.6. And I put this in a calculator to get the answer. To get to the distribution list, I'll hit second distribution. I choose the second one, normal CDF. My lower bound is 30, upper bound is 40, mean is 33.5, and standard deviation is 5.6. Enter, enter. This is my answer. And let's round to 4 decimal places. This digit is 3, so I round down to 0.6111. And I'll convert this into a percent. That is 61.11%. Example. A scientist finds that the heights of a certain tree are approximately normally distributed with mean 20 feet and standard deviation 4 feet. A. Find the percentage of trees that are between 10 inches and 17 inches. X is the height of the trees. The data is normally distributed. Mean is 20 and standard deviation is 4. Question A is asking for the percentage of trees that are between 10 inches and 17 inches. Let's put these all in the graph. I have a normal distribution with mean of 20. Both 10 inches and 17 inches are less than 20 inches. So both 10 and 17 are to the left of 20. And I want to find the probability of the trees that are between 10 and 17. So I want to find this region. Probability of 10 less than x less than 17. I'll use normal CDF, lower bound, upper bound, mean, and standard deviation. In this region, my lower bound is 10 and my upper bound is 17. Mean is 20 and standard deviation is 4. And I'll just put this in my calculator. We need to get to the distribution list first. So second distribution, and we choose the second one, normal CDF. Lower bound is 10, upper bound is 17, mean is 20, and standard deviation is 4. Enter, enter. And this is my answer. 0.2204 175,996. Again, the question didn't give us any routing instruction, so let's just round to 4 decimal places here. This digit is 1, so I round down to 0.2204. And the question is asking for a percentage, so I convert this to a percent, which is 22.04%. Question B. Find the percentage of trees that are less than 23 inches. I have a normal distribution with mean of 20. 23 inches is greater than 20, so 23 is to the right of 20. I want to find the percentage of trees that are less than 23. So this is 23, less than 23 is to the left of 23, so I want to find this left region. Probability of x is less than 23. I'll use normal CDF, lower bound, upper bound, mean, and standard deviation. In this region, my upper bound is the right boundary, 23. I do not have the left boundary because my graph can keep going forever to the left. So I just have to pick a really small number, very, very small compared to our data values. So in this case, I'll pick negative 1,000. Mean is 20 and standard deviation is 4. And I'll put this all in my calculator. Second distribution, I choose the second one. Lower bound is negative 1,000. For the negative sign, please use the button down here for negative. Do not use this minus sign. Upper bound is 23. Mean is 20 and standard deviation is 4. Enter, enter. This is my answer. And let's round this to 4 decimal places. This digit is 7. I round up to 0.7734. And I'll convert this to a percent, that is 77.34%. Question C. Find the percentage of trees that are more than 15 inches. I have a normal distribution with mean of 20. 15 inches is less than 20. So 15 is to the left of 20. And I want to find the percentage of trees that are more than 15 inches. More than 15 inches are the numbers that are to the right of 15 inches. So I'm looking for this right region here. Probability of x is greater than 15. I'll still use the normal CDF of lower bound, upper bound, mean, and standard deviation. In this region, my lower bound is 15. I don't have an upper bound, so I have to use a really large number compared to my data values. So in this case, I'll use 1,000. Mean is 20 and standard deviation is 4. And we'll put this in a calculator. Second, distribution. And then we choose the second one from the list, normal CDF. Lower bound is 15. Upper bound is a very large number, so I put in 1,000. Mean is 20 and standard deviation is 4. Enter, enter. And this is my answer. Let's round this to 4 decimal places. This digit is 5, so I round up to 0.8944. And I convert this to a percent, that is 89.44%.